All right, can everybody in Zoom land hear me?
So anyway,
Get a thumbs. All right, there's a thumbs up. Thanks, Scott. Okay, so this is going to be session 4, which is software engineering and the user experience. I can talk louder. Alumni experience. So we have some great speakers in session 4. Really happy to have so Adam Shiri is a senior software engineer and data engineer at Microsoft and is an alumni from 2004. Then we have Mary McInnes, who's a UX researcher at Bold Insight. We have Andrew Spina, who's a software engineer at Amazon, and we have Adam Jones, who's a Detroit domestic representative at National Counterterrorism Center. So we're going to start off with Adam Shiri, and throughout this presentations, they're going to give their presentations, then have a panel afterwards for questions.
So just to get a kind of feel for who's here, do we have any, I know we got a couple high school students, do we have any current tech students in CS? Okay, good deal. You know, as Tim said, my name is Adam Shiri. I am a graduate from Tech from 04, my bachelor's in computer science. And I am currently a software engineer at Microsoft. I do data engineering work. My title is software engineer, and that's one of the things that I'm going to talk about is the terminology that we use here. So let's get this moving. So really what I want to talk about is some of the opportunities that exist in data science and data engineering. Are we good here? Okay. So, you know, last night there was this panel on the past, present, and future of computing at Michigan Tech. And there were a couple of folks that used this magic word, opportunities, that I really liked. I was really glad to hear this because that's really what I want to focus on. And it's really difficult to know what the opportunities are going to be. I don't have a crystal ball, and I can't predict what is going to be really important to know about in the future. And I can talk about some of the current opportunities. These are some opportunities on the left is more along the lines of data science. So I partner with data scientists, so I have some perspective on that, but I do data engineering. And so the things on the right are some of the topics in data engineering, and these all are topics from Microsoft's offerings for jobs that are out there right now. So I'm familiar with some of these to varying degrees. But the challenge here is that the different topics here, by the time you tech students, and especially high school students that are going through a degree program or getting into software and data engineering and data science, by the time you're working on these things professionally, this is going to be really outdated. And it's not that these things are going away, but they're going to further develop, and they're going to be subdivisions on these and learning just a little bit about these. I can't really talk about these very well right now in such a way that will be super relevant in 4 or 8 or 10 years. And so instead, what I'd like to do is think about where the opportunities are going to be by virtue of looking back at some different opportunities, both for myself through my education and professional career, and also for the industry in data engineering and data science. So this is essentially the summary of what some of the opportunities are, but hopefully we'll get to a little bit of more information on where we're going, where we've been. Now, one of the challenges that I found as I was going through my CS program at Tech was I had some missed opportunities with classes that I took. So I know that there's some folks that are in the industry right now here, and they really understand what linear algebra is for, but this is a big area that I missed out on. So for the folks that are in a degree program right now, or not yet, do you know what linear algebra is really good for? Shout it out if you know it. Exactly. So that's the problem that I had. So I took a linear algebra course and I had no clue what it was for, except for it was a system for, it was a means by which you could solve systems of equations. You could calculate eigenvectors and eigenvalues and transpose matrices and multiply them. But what does that mean? I had no clue whatsoever. And it wasn't until years later that I figured out that, oh, linear algebra underpins almost all of machine learning. If you know anything about machine learning, that knowledge is based on linear algebra. This is a huge area that I missed out on, and had I known more about linear algebra, I might have gotten more out of this class. So if you're interested in data science, data engineering, linear algebra is really, really important. And it turns out it's not mentioned anywhere in the class description. This is a current class description for this class taken from text catalog just a few days ago. So linear algebra is super important. Another opportunity that I missed personally was the artificial intelligence class. I did not take this one. It was offered when I was here. And this class does mention machine learning. I don't know exactly all the different things that are brought up in this class, but you've got machine learning, you've got presumably various search heuristics, you've got maybe SMT solvers and set solvers, possibly genetic algorithms, a whole bunch of different topics that are going to be very applicable to data science, data engineering. The third course that I saw in the catalog that will be really useful is data mining. So I think the artificial intelligence may be particularly relevant for data science, and I assume that the data mining will be relevant to both sides, to the data engineering and the data science as well. So classification and regression, so if you're building models, doing recommender systems, which I'm going to be talking about more in just a minute here. So this is a really useful course. I don't know that this actually existed when I was here, but this would be a very important course. There was talk last night about how computing is, really every field has computing, and computing is kind of the center of the orbit around which all these other fields go. So chemistry and mechanical engineering, material science, all these different fields really make use of computing. And I think data science and data engineering really form the core of a lot of what that is. So these courses can be incredibly important, not just to computer science, but to other fields as well. So I got my degree in CS from tech, and then I went into the industry. And then not long after, a friend of mine recommended to me, hey, you should look at this company, LexisNexis. They're not far from where you live. I think you'd really enjoy it. So I applied there and I got a job, and I started working within this company, LexisNexis Risk Solutions. And the work that I did was in the area of fraud detection, identity verification, creditworthiness. And my role as a software engineer, and I worked with our statistical modelers. So these statistical modelers, these folks really deeply understood the data that we were working with, since it's information about generally citizens in the US. And they would understand the relationship between various features in our data sets and what we were predicting. So how likely were you to repay your loan, for example? What was the probability of a particular request that was coming in as being fraudulent? So they really deeply understood the data there. They were able to identify when there were features in the data that were correlated, to be able to tease out those relationships. And then they were able to build models, understand where those models were really good and where they failed, so they could evaluate the efficacy of those models. And then in cases where the model was not performing well, they could identify different cohorts of those individuals and build different models to more accurately predict for those. Now, what does this sound like? This is data science. But we never actually called it data science. So as I mentioned, these folks, their titles were statistical modeler. But really they're data scientists. And I think that speaks to how the terminology that we use has changed over the last, this is only 15 years. 15 years ago, at least where I was, we only use the terms statistical modeler and software engineer. Now, for the work that I did, my title was and still is software engineer. But really it's data engineering. And even to this day, even within Microsoft where I'm working, we don't really have a great delineation between where does software engineering end and where does data engineering begin. And further, I think there's this kind of spectrum of you have coding or software engineering on one side, and then maybe you have pure data science on the other. And then somewhere along the lines here, you've got data engineering, you got machine learning engineering, you have ML infrastructure engineering, you have applied science, you have analysis. So there are a number of different places on this continuum between software engineering and data science that we don't have well defined. So the work that I was doing was in software engineering, but really this is where I got my first exposure to large scale, highly reliable, parallelizable data processing. And today you might see this in essentially Spark. Now, I'm curious for anybody who's been working at all with data engineering. If you've heard of HPCC Systems or ECL, the programming language. I didn't think so. So this is a missed opportunity from the perspective of LexisNexis. So they built a system that was really, really good at building data pipelines, bringing new code to production very quickly, building code that was very reliable, very fast, very low memory usage. It's fantastic. It was their competitive advantage for doing data engineering and also the data science along with it. And they ultimately decided to open source their platform. You can find it on GitHub. But unfortunately, they kind of came to this too late. They came to this decision too late, and the industry for data engineering really passed up what I think is a better solution than what Spark is. So if you know Spark, this is, I think, a lot better, having worked with it for several years. And that's a really unfortunate missed opportunity on their part, and also for the rest of the industry, that we have what very well may have been a better tool for high performance computing that we all missed out on. So I was a little frustrated with the difficulty in the portability of skills with ECL and HPCC systems. And so I decided to move on to a different role. And I went to Amazon for a little while, and I'm going to talk about the product recommendations, which is what I did there. But I'll come back to that in a minute. And then I went to Microsoft. And not long before I joined Microsoft, this blog post was published. And the title here, petabytes perfectly processed perfunctorily, is a reference to a Microsoft research paper that describes Cosmos. So this is all available publicly. Cosmos is a system that Microsoft Research built, and it was based on a previous system called Dryad. And Cosmos is essentially Microsoft's version of Spark or ECL. And so Microsoft runs a huge amount of data processing on Cosmos for basically every group within the company, from Bing to Office to Azure to Windows. Huge amounts of data is processed very, very quickly across thousands or tens of thousands of nodes. And Microsoft did kind of a similar thing. Microsoft released the programming language is called Scope internally. It's USQL publicly. And the internal system of Cosmos is published. You can use it on Azure as Azure Data Lake Analytics. So has anybody heard of USQL or ADLA? Has anybody used it? All right, we got somebody. Excellent. So I was not expecting that. Microsoft released this a few years ago, but kind of came to the party again too late. The industry has kind of coalesced around Spark. Again, much to my chagrin, because I think that Cosmos is actually a really fantastic system as well, and better in many ways than Spark. But this is a missed opportunity for Microsoft, and I'm hoping that there are other opportunities that we as an industry will advance to be able to make the data engineering side of things a whole lot better, a whole lot more efficient, a lot faster, more reliable, and so on than what Spark currently is. So I talked about some of the opportunities that I've had in this, and the industry has had in this as well. And I want to pivot a little bit and talk about product recommendations. So I worked on product recommendations a little bit at Amazon, and a lot of the product recommendations are based on collaborative filtering. And this is from kind of a seminal work on collaborative filtering from back in 1995. And this paper, Social Information Filtering Algorithms for Automating Word of Mouth, this paper kind of laid the groundwork for a lot of what happens with product recommendations. It has happened for almost 30 years now. And the idea of this paper is to automate word of mouth recommendations. So, how much do you think I'm going to like this new restaurant in town? Or given that I've bought these products, like what else do you think I should get? And this is totally ubiquitous to us now. But this paper was thinking in terms of being able to make automated recommendations on the scale of thousands of people and thousands of items. And we can kind of look back on this now, almost 30 years later, and say, well, 1,000 people and 1,000 items, that's peanuts. But this is where we were at as an industry almost 30 years ago. That's kind of where we were going to we were going to aim for being able to do that. And then about 10 years later, the Netflix Prize came out. Have you guys heard of the Netflix Prize? See some nods, yeah. So the Netflix Prize was started in 2006, and Netflix's goal was to be able to improve the product recommendations, the movie recommendations, by 10%. And with a prize, if you got to that point, you would win a prize of $1 million. And what they did is they released a data set of 100 million training records. And so they look kind of like this. So for one particular movie, all these different users rated this movie with this many stars on this date. And the numbers here, like 1488844, that's the anonymized user ID. So they released this data and they said, improve our algorithm. And so people took this information and they started building better systems than what Netflix already had. And then within 2 years, there was a winning team that got the prize. And what happened is the system that they had was an ensemble of many different approaches. So it was rather complicated, but overall, the high-level description is they came up with an iterative approach that would factor the item and user matrix, and they would produce recommendations for any user. And from what I've seen, the approach they took stopped after 10 iterations. So they had diminishing returns. They stopped because it wasn't worth the effort to run anymore. Each iteration took about 3 hours. So this team was able to train their model basically in about 30 hours. But over time, there were improvements that were made to this process that were able to actually parallelize it. So instead of running the training algorithm on one machine for more than a day, you were able to do this over multiple machines in an order of magnitude less time. So this is a great improvement in the data engineering work that was being done for this particular use case. But then even improving on this further, and this is not all done by the same team, there was an approach that used deep learning, so convolutional neural networks, to do latent feature extraction from the data set. So at a high level, to think about this, instead of saying these users really like Tom Hanks movies, or these users really like horror movies, for example, or they like Quentin Tarantino films. Instead of something very easy to describe like that, the latent features extracted by the convolutional neural networks are incredibly hard to describe, but there's some there. So you can actually get features that you know are accurate, but it gets beyond the way that we can really think of the simple mapping of users or features of a movie. And so these are some improvements that have been made over several years to this very simple idea of doing collaborative filtering. Now, there's one more thing that I want to talk about here, and that's differential privacy. Now, I mentioned that the users in this data set were anonymized. They took the user IDs and they just put numbers in there. However, 2 years after the Netflix prize was started, right around the time that they awarded the prize, this paper came out from these two researchers at University of Texas at Austin. And it's called Robust De-Anonymization of Large Sparse Data Sets. And what these researchers found was that using some side channel attack, they took movie ratings from IMDb, and they were able to map those users and those ratings from IMDb over to the anonymized data set that Netflix had released. And they were able to re-identify the vast majority of users. And this is actually a really big problem. Now you might think, well, this is just your movie ratings. Why is this a big deal? And it turns out that there is a federal law that prohibits the unauthorized release of movie rental information. So this is published. This law came out was codified in 1988. So it was all about movie rentals. But Netflix's data is subject to this law, and so Netflix broke the law, presumably on an order of about 500,000 instances, by virtue of releasing this data in such a way that it was not sufficiently anonymized. So differential privacy is this idea of being able to ensure that you have appropriate privacy for any individuals or any records in a data set, while still being able to maintain the statistical aggregate information of the whole data set. So in other words, thinking about Netflix's data, being able to identify that certain trends exist, certain patterns exist in the data set overall. So these kinds of users will enjoy these kinds of movies, without being able to identify, for example, in the headline here, that a closeted lesbian mother was in the data set. So that's the kind of information that differential privacy aims to protect, while still allowing to have us to have the efficacy of the statistical aggregates across the entire data set. So just thinking about this path on the collaborative filtering subject. From almost 30 years ago, we went from we can automate word of mouth recommendations for a few thousand people to being able to do this 10 years later for 500,000 people or even more, to being able to do that 10 times as fast, to being able to extract features that we can't really explain, but these neural nets can, to then being able to protect the privacy of individuals while still getting all the efficacy of everything else that we've done across that entire path. So there are so many different opportunities that we've seen just in this one track over the last almost 30 years. And this is going to continue on for the foreseeable future. So as I wrap this up, I hope this has given some sort of a semblance of the incredible number of opportunities that have existed in the past, and hopefully we can use that to project forward that there are going to be so many more opportunities. The last thing I want to say is that, you know, I do data engineering work. That's not a term that I had ever heard until maybe 7 or 8 years ago. I was well into my career at Microsoft before I even heard this term used. And that changed the way that I have thought about the work that I'm doing. I always thought of myself as a software engineer, and now I'm starting to shift my mindset into data engineer. And working with data scientists, I'm continuing to shift my thinking as to what opportunities exist for me and for everybody else in the industry. And so that's where I want to end for now. And I think we're going to take a couple of questions, and then I'm going to hand it over to Mary.
Following up on your this kind of description you have of this continuum, software engineer, data scientist, thinking about from our perspective, preparing students for this. What any insights for us how to do this? You know, we have a software engineering degree program. We have data science program.
Right.
What would work well in terms of blending these and allowing students to kind of work well in that?
Yeah, so just for the folks on Zoom, so I think the question, if I can accurately represent it, is how do we make sure that we prepare students for this? And then you're asking about kind of blending software engineering and data science. So hopefully I touched on it a little bit with my challenge through taking some of these classes was, well, there are at least two challenges. One is I had no clue that that linear algebra was useful for anything except for very abstract concepts. And so I think being able to accurately convey some of the importance of some of these things would have at least helped me a little bit. There's another challenge that I personally found. I don't know if I have a great answer, and that was, you know, I didn't know that don't think I even heard the term data engineer until really just a few years ago, which is shocking given that I had been in big tech companies for a few years. And so, you know, I always thought of the work that I did as software engineering, and that's what I thought that I would be doing. You know, when I was at tech, I thought I would be doing software engineering, but I had no clue what the nature of the work would be that I would be doing. You know, I took a compilers class, for example, and thought that was a really useful thing. Turned out to really not be particularly useful for my career. So I don't know if I've got a great response to that, other than I think ensuring that students, you know, we talk about the T-shaped career, making sure students have definitely that breadth of knowledge, different topics to look at, and then also making sure that students really understand that the classes that you take here are not going to be the tools in your toolbox. It's really the ability to learn and shift around and understand that you have to project yourself forward to where is the industry going. Hopefully that's kind of the best way to prepare students, but I don't have any better answer than that, I don't think. Any other questions? Yeah.
I guess, yeah, you kind of answered it with the previous question, but like for data engineering specifically, as you, I guess, understand it today as best as you might be able to, right? If like let's say you like Michigan Tech create a class, Intro to Data Engineering.
Yeah.
How much could that class possibly prepare students for like working at a large tech company or even working with big data in general, right? So
Yeah.
it seems like, maybe I'm just answering the question also, but like from my guess is that like the types of problems can't possibly even be attempted at smaller institutions or even larger institutions for that matter.
Yeah, so that's a really good question. So the question is, if Michigan Tech were to create a course on data engineering, how well could that prepare students for doing work at a small or large company doing data engineering? Is that accurate?
Yeah.
So I think that the data mining course is probably pretty good. Again, I don't know that it existed when I was here, and I didn't take it. So there's the aspect of, what is the industry currently coalesced around, and the answer to that, I think, is for the most part Spark, PySpark, Python, pandas. Being able to really think about data sets. I know that when I started working in large-scale parallelizable data processing, wrapping my head around basically joins, database joins, and how data are moving around across many machines, like that's a big challenge. I think that is one way, being able to think about data, not in terms of I have a few rows in memory, but really I have data clustered around tens or hundreds or thousands, or even tens of thousands of nodes, and being able to think about processing very large data and bringing the compute to the data, as opposed to moving your data around. I think those are some of the challenges in being able to be an effective data engineer. Using those tools like pandas and Spark, for example, I think would be a really good first step to being able to say, look, this is what the industry is using. I don't know if what tech is currently teaching in terms of languages, but it was Java primarily when I was here, as well as a little bit of C++. And the industry still uses Java, but is like among data engineering, it's very much Python as well as Scala. So perhaps some migration over to what we're currently doing. With that said, I do want to also call out that, I said that Spark, I think, is somewhat suboptimal for a lot of really high performance stuff and high reliability. And I think there are some opportunities, because that's kind of the theme here that I want to impress upon, that there's some opportunities for new technologies that are coming out. So instead of pandas, there's another library called Polars, which is much more parallelizable and high performance. And then there's also Ballista is a system that may replace Spark at some point. It's still kind of in its infancy. And so potentially being able to see what's coming next and be able to get students to look at, these are some new technologies that might be where you will be in 5 years, potentially. So those might be interesting things. And the other thing for me, I've partnered with data scientists for almost 15 years, and being able to at least understand what data scientists are doing. Like, I had no clue what linear regression and logistic regression were when I was at Tech, and even for the first few years in my career, and understanding what those were, like really fundamentally understanding it, so that I could have intelligent conversations with these data scientists, and really know what they were trying to do, and then be able to be a good engineering partner for them. So being able to have the nomenclature and have these knowledge of these subjects is also really useful. So taking maybe a few data science courses can potentially be useful. Okay, so do we have any other questions? Okay, so with that, I'm going to hand it over to Mary.
Hi, everybody. I'm Mary McInnes. I'm from Bold Insight. It's a global UX research consultancy, but I started off here at Michigan Tech getting a mechanical engineering degree. I ended up here by a very unconventional path, but let's start off with, if we are even on board with what UX is, who here is familiar with the term? Is it a big part of what you do when you consider things in computing? Do you partner with that building that I saw that had a big sign on it that said human factors? So these are the kinds of questions that I have for you to begin with. So how familiar are you with UX? Okay, we're going to go with you. What you got?
I'm familiar with it, yes. User experience. And we have yes, we do have a connection with people in the Hackers program. It's crossover. People in the learning science department.
Awesome.
Computer science. Yeah. And there's some work on HCI and user experience stuff in our software engineering degree program.
Excellent.
So there's some.
Yeah.
Yeah.
Okay, thank you. That helps me a lot. Yeah, with knowing what direction to take this in too. So yeah, it's user experience. And I like to say that It's the irrational part of the very rational work of software design or any product design, because we can't predict what humans will do. So there's the input, that's the, you got your input and your output from your program, but the input isn't always as easy as what we think, because it does come from a human. So here's the next one. Hang on a second. My tab isn't working. Why don't we try that? There. All right. So this is me as a human. I have a very unconventional path, I mentioned. I'm a Youper first and foremost. So I was born in Escanaba. I then spent my years through college here, but then I ended up in different places after that. So what you see here on the right is our excellent marketing department at Bold Insight. We gave away Christmas presents to our clients that consisted of meaningful recipes from all of our different staff and researchers. And so anybody here Finnish? Anybody got any Finnish blood in them? Yes. Yes. Okay. We're a minority here, which I didn't expect, but it was true when I went to school here too. It was all the trolls, right? Everybody from Lower Michigan. But this was a recipe that I have grown up with and I continue to make to this day. My work is meaningful not just because I get to share recipes with my clients. It's meaningful because I made sure it was. It's meaningful because the nature of the work that I do makes sure that the needs of other humans are met. So I'm a Youper, I'm a mechanical engineer. I did automotive engineering, I worked for Ford, and I also worked for John Deere. And that career lasted me about 10 years. And I did a lot of designing to specification. I did a lot of quality engineering, running failure mode and effect analysis. I did a lot of things that were extremely analytical, but didn't connect me very much with the people that would be using their products. And for me, I needed more of that. So I actually got out of engineering. It's a lucrative field, but I said, yeah, I need something else. So I tried teaching math at the university level as an adjunct instructor. So I'm like, that's going to be meaningful because I love math and I love the theory and all that. And so maybe I can inspire kids to go down a path that's more STEM-like or something. And what I found out is that as an adjunct, you just get the courses that none of the professors want. And you end up with a lot of students who don't want to be there because they have to take their one math credit. And so I moved on from that. And so the next logical step was yoga teacher. So I became a yoga teacher. I opened up a studio, and that's where my interest in psychology began, actually. It began with Eastern psychology, which is the basis for good yoga. Right? If it's not going to just be about your body, it's obviously going to be about your mind. So my yoga experience then led me into some other things. It actually led me into being a writer, being a mountain bike racer. We'll talk more about that later if anybody wants to. And then ultimately where I'm at now, a human factors engineer, working as a UX researcher. And I feel like every single thing informed what I do now. All of these things informed what I do now. So you're used to working with the quant, and we do a lot of qualitative stuff. And I think that the biggest takeaway here is with computing, you can find out what, and with UX research, you can find out why. Oftentimes we're at the very early stage of product development. And that stage would be generative or exploratory, like predicting what product the world needs next. And we can help companies do that. So that's what I get to do as part of my job. And then I also get to do validating that that actually does meet the needs that we anticipated. So those are two sides. One of them is kind of more creative, and the other one gets a little more into analytical stuff. Analytical skills that you guys gain in programs here in computing are going to make you successful in just about any discipline. So if you can think in logical operators, and if you can think with the efficiency of nested loops, right? That, if you do that in any role, it's going to serve your organization and humanity, okay? So that's one of the things that you learn in computing, is how to do that. I don't have any formal computing background. I did end up learning Android Studio in my psychology master's program, because I needed to collect some data and we needed to make an app to do it. So I learned Android Studio. Okay, who loves it? Anybody here love Android Studio? Okay, because it's a rough one. Prior to that, I started taking computer science courses at University of Northern Iowa because I didn't know what I was going to do next with my life. I didn't know how to put all this stuff together. So one of my options was maybe something in computing, and I really liked coding, and I learned C++, and I really enjoyed that. But my big takeaway was always that the same things that make you a good coder are the things that can make you efficient and effective at so many other things. So we focus on qualitative. This means we see how people are actually going to use the products. This means not great big quantitative studies with large sample sizes. We do smaller sample sizes, and we find out what people are really doing, and then we make sure that the product does a better job of telling people how to use it. So this shows some of the kinds of things that we measure. These are typical things in UX. So UX could be digital products, but a big part of our work is actually in the medical device space. So these are physical products, and since most of our business is divided into these two categories, digital space and then medical device physical, we used to kind of look at those quite differently, but they seem to be coming together. So if you've become aware of things like connected health, smart, basically smart health, oftentimes any medical device will come with an app. So that's what's happening as the two sides of our UX business are starting to converge. There's a lot of carryover between these two sides. Psychology plays a big role in this, but also the ability to analytically think, to break down a problem into easy steps, and to break down the solution into things that are easy to implement. So I really just want you to take a look at the things on the bottom here. These are different ways that we can go about doing research. And oftentimes these come with software. We are maybe sometimes even trying to figure out ways to use software in ways they weren't intended to be used. We currently use, for instance, in that bottom first row, diary studies. That sounds like it's going to be somebody sitting there with a diary, but there are all of these apps now that allow you to collect really rich information. People can essentially vlog and send it right to us so that we can see how they're interacting with products. They can do screen recordings. We can collect a lot of data that otherwise would require us to be there with them. So it's cost effective. And the industry is booming thanks to this pandemic we had. So the industry for tools like that, for remote data collection tools, is really big. In the middle column, you can see we do a lot of analysis of things like information architecture. Can people navigate through a site? Can they figure out where what they need will be? Are they going to have a logical flow to that? And then in this last one, it talks a little bit about how we do in-person studies. So I just came off of an in-person study on Friday, and then got up Saturday morning made my way up here to enjoy the UP a little bit before this. But an in-person study requires a simulated use environment. And we want to make sure that it's ecologically valid, that it makes sense, that that it's what people would actually do. So we create an environment. Sometimes we're testing whether a healthcare practitioner can properly figure out the use of a medical device. Sometimes we're testing patients, caregivers. So the med device side, then, what we're trying to do is find out what these irrational humans, because we all are really going to do given this product. So our business also expands into other areas. Having come from the automotive space originally, we do also have that kind of work in our company. We've done infotainment system research for both automotive and air for planes. And we have the ability to simulate those environments too. Or set somebody in a car and set up all of our equipment to capture the data that we need in that car. And for those of you who are, like me, looking for meaning, needing my work to mean more than just that I could distribute the right volumetric flow rate of air to the passenger in the middle of the back seat, just kind of human factors, I might argue, because it's about comfort. But if you want the kind of meaning that you can actually really feel, kind of more salient meaning, then working in a space where you work with people who have needs that aren't being met, and you can make a difference. And so in this case, it was voice technology for visually impaired and blind users. We've got a lot of case studies, and I thought I would just throw a few of them up here just to give you some ideas of the kind of work that we do and the kind of work that UX researchers more generally do. But this one is one of my favorite. And it also gets into voice-enabled task flows, which is on the bottom right. You can see a little bit about that. Well, what are task flows but if-then statements? It's more about your logical operators and your loops and things. And so you can apply that in this kind of work, and it will be different every month, right? I'm on a new study every month. I'm turning around an entire new research project in approximately one month's time. I enjoy that. I'm that kind of person. I actually, I'm a novelty seeker. Okay, so hence the mountain biking and some of those things. I'm seeking novel experiences, and this serves me really well because of that. Journey mapping, anybody familiar with that? It is usually upfront to any software design. You want to know, what is that path through the interaction with the product, or prior to that interaction? What gets them there? What are the different branches that they might take once they're in it? So this sounds simple, but scheduling appointments with your healthcare practitioner. All these things can be done better. All these things can make it easier for people to use them and then get the services that they need. So we do partner with a lot of big companies to do a lot of fun things. We are often the first people to see the new tech. That's one of the best parts of the job, but it's also one of the hardest parts of the job, because all I want to do right now is tell you guys the cool stuff that's coming out, and I can't. It's all proprietary. But just know there's a lot of cool stuff coming out. And it's really fun to be able to see that ahead of time and to help our clients shape that in a way that best serves the needs of the people that they're trying to serve. And I must say, we are hiring. Okay, we're hiring. And we are voted best place to work. We're in Chicago, but we are also all over. Our studies take us everywhere. I've only been at this company for 1 year, and I've been to LA, I've been to New York City, I've been to Boston, I've been to Minneapolis. Oh gosh, and I'm forgetting places, and definitely Chicago. So there's a lot of demand now for UX. It's finding its place, particularly in the med device industry. There was a high need for it because there were so many errors. And so now the FDA makes sure that human factors testing is a part of okaying a product before it hits the market. So there's a lot of work now that can be done to make sure that there are fewer errors, that people can use these devices and they can benefit from what they were intended to do, which is a big part of what we do. All right, so I guess what I'd like to say now is, yeah, I'd like to say, any questions? How about that? Yeah. I know it's a strange field to be talking about at the computing showcase. And I told Amanda that when Amanda asked me to come, she organized this. Everybody, Amanda, okay. Well, fact is, it's all interrelated. It's all connected. And it makes sense for me to be here. And so I'm really glad. Thank you, Amanda, for inviting me. Yeah, were you gonna actually ask something?
I was gonna ask, yeah, something.
Yeah.
By the way, they're actually doing work in the space here, so
Yay.
hopefully we'll talk about that later.
Yeah, I would love to, yeah.
But my question is, your work to date, what are you, does your company tend to kind of come into a scenario, kind of parachute in, you know, the on-site observers, hey, we need some insights on this, versus sort of being there through the evolution of a product? Do you have
Yeah, it
where they're
depends.
sort of like long-term, or are they
Yeah.
kind of like, hey, we need a quick study, you know?
Yep, and it depends, we do it all. Yeah, so right now I am on the 4th iteration of one medical device that we've been testing out for, I don't know how long, because it was before I got to the company. And so some of those things, yes, you can see the progression of what the difference that your research makes, what we find out and how it informs the design and then iterate. So typically in the med device space, we are hired to continue through the iterative process from formative all the way through summative or validation studies. But that sometimes we will be hired just to do a one-off thing, just to get an idea of an opportunity space. What does it really look like out there? We've done some of that for opportunity space in AR. Always important to drop AR when you're around a bunch of computing geeks. But yeah, so, you know, we do, it's very diverse what we do. Yeah. Okay, thanks for the question.
All right, great. So my name's Andyspina. I'm here from Amazon. I've been writing software primarily in Java for about 15 years. I graduated electrical engineering here at Michigan Tech, participated in the swing club and on the Ridge Roamers, lots of great stuff around here to do outside of your classes. Strongly recommend all that. And I'm very fortunate because I get to work with data engineers and usability experts and designers. And so what I'm going to talk about are some of the specific things that I do as a software engineer, just so that people can understand a little bit about what it's like working on software professionally, because it's not like solving problems in your classes. It's a very different thing. It tends to use a wide set of skills. I've done a lot of learning about usability, a lot of learning about data engineering, and those things support me. So you can talk about all these professions as being discrete, but in reality, they're just skills, and different jobs require different skills. And in the end, you have a job title, but learning these skills, even if it's not what your title is about will almost always be of value to you, right? So I very much recommend that people work on a variety of things, learn a little bit about ML, which is not something I like working in, but I'm really glad I understand it. So I understand when it's the right tool to bring in, and I know when to engage other people. So my talk is broken into, let's see, 3 parts. I'm just going to talk 3 little anecdotes, vignettes about things that I've done or that my teams have done in software. So the first thing is going to talk about error codes, right? And error codes are kind of a funny concept, you know, but it's really important in software, how you handle errors. And so I'm going to talk through this page, which is a page that my team currently owns, where customers upload files to change the things that they sell on Amazon, right? So sometimes the files are big, 600 megabytes is our maximum size we allow, and they're Excel files. And if you sell on Amazon, you can use this page right now. And when you upload a file, sometimes you get this little red mark, and there's designers and stuff that have figured out the colors and all of that stuff to try and make it so that we have a nice experience for our users. And that red mark tells you that I uploaded a file that doesn't, it was generated using a different account. But that's not the part I'm going to talk about. I'm going to talk about that little gray text there, which I chose to put on this page. I'm a software engineer, and I sometimes get to make decisions about web pages, and that's pretty cool. So why did I put it there? Because, you know, I could just, if there's a problem with the page, the customer doesn't need that gray code. They need the black text, right? But of course, we're an international company, and sometimes this is what the page looks like. Now, and you have to really think through customer flows. What's going to happen is my team has an on-call who handles tickets. And a ticket is a contact from a customer that our first line support couldn't help, right? So seller support gets a call, and the customer says, why am I seeing this, right? And they say, I don't know, I'll send it to Andy's team, right? They don't know me, but I know them. And so they'll take a screenshot and they'll put it into this ticket. And one of my, either me or one of my engineers will see this. And if they don't speak Japanese, they're going to have a problem, right? So we chose to put this gray text on there, even though for a customer directly, it doesn't help them, but it dramatically reduces our diagnostic time, because now I don't have to figure out who the customer was, what instant they loaded this page, so that I can dive into my logs and see what error code it was. Because, for example, I can't even type this on my keyboard. I don't know how. So I can't put this into Google Translate. So I can't figure out what went wrong necessarily. So you can shortcut all of that by making this somewhat dubious customer experience thing. You know, Apple generally wouldn't do this because they don't consider it acceptable to show these kinds of error codes on screen in an iPhone app. But we made this decision because we work with professionals, and for them, the most important thing is getting something fixed quickly. So how do I use this when I get this gray text? What do I do? Well, I can go into my code base and I can paste it into the search box, right? It's really, really nice that when I do that, I can see the code that emits this error, right? So if there's a bug, if I get a ticket because someone should be authorized and they're not, then it's very, very quick for me to find the line of code amongst hundreds of thousands of lines of code in some of our code bases that gives me the problem, right? So now this is a usability problem for the engineer, and shortening that cycle for them to figure out the solution really, really helps them. And if you dive a little deeper, you can see underneath that blue line, there's a definition. This is all in Java, but that's an enumeration. And it tells you what text is being rendered and how that text is looked up. And you can see that there's usability considerations as well, where that exception contains text and it includes the input data, which makes it so that if you're looking in the logs and you see this exception, it becomes very easy to figure out which customer triggered this exception with what data, and all of that really helps. And so anyway, as a software engineer, these are the kinds of things you get to decide, right? And naming is important. When you read this 5-line block of code, it's relatively easy to tell what it does. It asks some other system, a service, whether there's permissions, and then if there aren't, then it fails. And that's kind of cool. But then we throw this exception, feed upload exception. And if you don't know what an exception is, it changes the way the software control works. Instead of the pointer moving downward in the code, the pointer starts moving up until some piece of code catches it and decides what to do. So an exception is thrown, and then you've got a catch block. And in our catch block for these kinds of exceptions, we count a metric. And so that metric means anytime you record one of these new error codes for free, you get metrics on how often this error code is emitted by the code. And you'll notice that over the last 100 days, there's been a dramatic increase in the amount of this specific metric. And that's really important because in aggregate, a data scientist wants to be able to do an analysis and figure out, is there a trend? Did I get this ticket because there's one weird customer, or did I get it because the software somehow changed? And in this case, it did. We exposed this functionality to a much wider set of customers. So now we're seeing more traffic. And that has to do with really just understanding your software and knowing where this is. And if you don't know why it's increased, being able to do that deep dive and figure out what happened. I am guessing I'm taking way longer than I should, which means I might not get to go through all of these. All right, cool. So now we're going to talk about another user experience. This one is kind of fun. It's about the tiny little piece of this page. This is the Amazon product search page. You may or may not know, but Amazon sells a whole lot of products, and this is a very core piece of how we sell our products, right? Because it's about product discovery. So it's got some important features. Some of them aren't on screen. For example, it always has to work, right? You know, if on Black Friday or Cyber Monday, you log in and you do a search and it doesn't work, that's a terrible thing for you, right? And we're a very customer-focused company. We want you to be able to buy, right? That's good for you. It's good for Amazon. It's good for the sellers who I serve when they put their products into the catalog. So you look at this page and it's got a bunch of features on it. All right. There's the results and there's some filters, and at the very top, there's the search text. And so you have to understand that when your shopper's there, they're on the search page. And then they're going to be, that search page is going to be reading from a database. That's the little cylinder in the middle. And then there's other systems, other software that's writing into that database. And those things happen at very high volume. There's lots of products. There's lots of people editing the products. There's lots of people reading the products. And they're asynchronous. So for example, when you look at this little piece here, 2 results, that might change. You know, you might do a search, and then you run the search again and it goes to 3 or 5 because someone changed the catalog, or it goes down to 1 because a product was expired and it's no longer valid, or we discovered that it was fraudulent and we cut it out, right? So we're going to talk about the usability of this and specifically how it affects some of the engineering decisions that you end up making. So let's look at how it changes based on the number of results. So this is a very specific search. I filtered out as much as I could because I wanted to get very few results. And then I made it so that there's more. And you notice the text here changes. Now it tells you we're showing you 16 results, and there's 194 products total. And then it changes again when you get to really big numbers, right? And now this is a decision that someone got to make, right? And needed to make. That once you get to 40,000, probably doesn't matter if it's 40,002, 40,006. So we're allowed to round here. And that's a requirement that you get from your business people, or you work with your business people to define it. And it's really, really, really important. It doesn't seem like it is. As a person, right, as an average shopper, you don't look at this and think, oh my gosh, this totally changes the engineering considerations of this product. But in fact, it does. Because basically in databases, there's a trade-off that you make. You can have something called a highly consistent database, that's approach 1, or an eventually consistent database, that's approach 2. A highly consistent database basically understands the whole world at every moment in time. And so it's got a single point of failure, right? And the way that you make it so that when it fails, because all software systems do, is you route all of your requests to your database through some sort of switch. And then you can flip that switch and switch from a primary to a secondary database. And you see these green arrows are replication lines. So when someone is writing into the primary database, it gets stored in the primary database, and then there's a system to replicate into the secondary database. Now that one, it can always tell you exactly how many rows there are in your database, exactly how many products your search found. And that's pretty nice. And it's really important for certain kinds of systems, like financial accounting systems, right? You don't really get to guess at how many dollars there are in an account, right? You have to be very precise. Now, approach number 2 is a different approach. When you receive a write, there's actually 3 or 4 copies of the data floating around. And each of those copies is responsible for persisting a result and then saying, I persisted the result. And then the replication goes through this sort of ring in order to make sure that the data all gets in there. And there's a lot of complexity in database technologies, and I'm just trying to talk about it at a high level. But if you're searching and you get to, say, 1,000 and you don't need to be precise anymore, then you can use approach 2. And approach 2 is fantastic because it does something called horizontal scaling. So approach 1, when you add more data to your database, right, you've got typically one really big, beefy piece of hardware, right? It's sitting in a data center somewhere. And if it breaks, you've got a switch, sometimes a physical switch, that moves you to that second database. And that's great until you need a bigger machine. And at a place like Amazon, or really any tech startup that's looking to scale to lots and lots of whatever it does, you don't want to buy a $500,000 machine. Or even worse, you don't want to find out that you need something bigger and no one makes it. Because then instead of spending another $30, which is what these horizontally scaling solutions do, in order to add more capacity to your system, what you have to do is you need to go and figure out how to either totally re-engineer your system. Now, Amazon did this recently, years ago. I've been there for 8 years, and moved generally to approach 2, because approach 2 allows us to say, if there's more data, we just add another replica in, and you just keep growing that way. And it drives down costs. It makes things harder to think about, though, because now when you write data, imagine you've got 2 or 3 clients writing into this this replica, one of these replicas. They might disagree about the data, right? One might be buying a product, and one might be increasing the amount of products inventory for that product. And when that happens, how do you resolve those conflicts? And anyway, like I said, this is all super simplified view into Amazon systems. There's a whole lot going on. Okay, so now let's talk about another thing that we do frequently. Amazon uses microservices. Does anyone know what a microservice is, or what a service-oriented architecture is? It's basically the idea that instead of building one giant binary and putting it onto your host and it knows how to do everything, what you do is you break that binary up into logical pieces, and you put those on different hosts so that they can all change independently. And what that allows you to do is scale your development so that you can take teams and say, all right, you 10 people, you get to work on 2 or 3 of these little clusters of code, right? And then those teams can talk to each other through an interface, which is an API, right? Just like a JSON or a REST API. And as long as that interface is preserved, you can continue to add features and evolve those systems independently. And that's a really important thing for a company like Amazon, because you can't fit hundreds of thousands of developers into one giant binary. It doesn't work. So calling services is a pretty fundamental thing at Amazon. And if you're looking to become a good software engineer, I recommend you learn about that. I don't know if to what extent tech teaches you about that. But if you're using AWS, you're using services, because when you call DynamoDB or S3, those are services. They just happen to be really, really big, very general services with a lot of history and things like that. But you can imagine more simple interfaces that exist to hold product search, like this one. So again, a simplification, but imagine that Amazon.com is one cluster of services, and it needs to be able to talk to the Amazon catalog. And so we want to call the Amazon catalog. And then we've got this other thing called a cache. A cache persists data inside of it. It's kind of dumb. It just says, it's like a hash or a key value store. You put data in under a key, and then you can pull the data out under a key. And over time, that data expires and things like that. So on a good day, when our Husky customer over here calls and asks Amazon to do a search, that search may have recently already been executed. And so you get a green result. That means a success, right? You don't get a failure. You get to find your product on Thanksgiving Day. And so that's called a cache hit because we hit the cache. Now, what else can happen, right? We can have a cache miss where we look in the cache and the data is not there. And then we go on and we go into the Amazon catalog and it does this computation. And generally, when you have a cache miss, you take the data that you got and you put it into your cache. And again, there's lots of complexity here because caches can be either on your host or off your host, or you can have them be multi-layer, and there's a bunch of really cool stuff. But this is the core discussion about something called operational excellence, which is where you're talking about how do I make it so that my service appears to be reliable, even though the internet and all the other services are unreliable, because this Amazon catalog team could deploy bad code and suddenly break their system, maybe for a lot of requests or maybe for only a few. But when that happens, you still want Amazon.com to work. And so if you have a hot cache that's green for a certain search, even if the catalog's broken, you can still serve up meaningful experiences. All right. But what happens if one of the hosts is broken? Maybe it's got a bad network card or something like that. So first you call the catalog one, right? And there's some complexity here because you don't pick the host you call. There's a connection pool and you just kind of connect to one randomly. And sometimes that connection breaks. But let's imagine that host one is broken. So what can you do? You add a retry, right? And a retry says, well, let me try again because maybe someone, maybe there was a problem with something in that long set of physical hardware between your customer and the data that they need. So you add retries, but then let's say that the catalog deploys a totally broken thing. Well, cool. Now all of the nodes are red. That's bad because now no matter where we try, as many times as we try, it's broken. And that also has a side effect. I'm going to talk about, so let's see. So what I want to highlight here is that handling these situations is one of the core parts of software engineering, at least in a service-oriented architecture. And it's really interesting and subtle because if you turn on retries, something that you introduce is this risk of now Amazon.com, when the catalog has an outage, is going to send at least some multiple of traffic, right? Because it's going to try 3 or 4 times. And that most of the time, if you're talking about thousands of transactions a second, multiplying that by 3 is going to make it so that the Amazon catalog can't recover. It may not even be able to deploy because now it's got all of this traffic. And that's called a retry storm. A retry storm just means that because of an outage, you can't recover from your outage. And it's something that's really fun to think through. There's a lot of interesting mathematical behaviors. There's some really cool white papers about retries and how to reduce them, whether you wait a little while before you try again, that can really help. And techniques to reduce or manage the number of retries. So when calling a service, you want caching, you want retries, you want logs and metrics, but you don't want storms. They kick them when they're down pattern. You don't want timeouts because when you retry, you're extending the amount of time that you're trying to answer the question. And then that in turn increases the number of resources that you're consuming, which can cause starvation. And in general, you can add a lot of complexity by building these things out. And that complexity is bad because it only affects your system during an outage, which is the time when you don't want to be thinking about the complex things. You want to know how to execute on a fix. You can also run the risk of caching bad data. Let's say the catalog starts returning bad data, you put it into the cache. Now what do you do? Because it's going to live in the cache for a while. So anyway, I love talking about this stuff and I've overstayed my welcome possibly. I don't know what this is here for. Thank you very much. Hopefully in this time, I've convinced you that software engineering is really interesting. It's multifaceted. And I am actually not very much like our UX designer. I really like long-term ownership of something and slowly evolving it. And so that's, if that's something you like, maybe software engineering is for you. Any questions?
So you went to tech for electrical.
Yeah.
What did that transition look like for you personally? How did you go through that?
I like that question. So I graduated electrical engineering. About my third year, I realized I didn't love the practice. I liked the math and I was pretty good at it, but I just didn't see it as being fulfilling for me. And so I came back to tech for some postgraduate studies. Didn't end up getting a master's or anything. But what I learned was that I really love coding, right? And so if you love coding, this is a great profession for you because you get to do that. And coding is subtle and it's interesting. And one of the beautiful things about it is in my time as a programmer, I've worked for a metals company. I worked on the Hubble Space Telescope. I helped prepare the James Webb Space Telescope's ground system. I worked on large scale systems at Amazon in a variety of things, including Business Prime, which is a prime product for businesses. And the cool thing about programming is it tends to be in demand and useful wherever you go, right? And so whether you're professionally a programmer or a business analyst or a data scientist, being able to write code is a transferable skill. And what I love is I can go to any business that I want to work for, and chances are they've got a place for me. And I can learn a lot of stuff. I knew about photonics from my electrical engineering, and I get to apply that to my work on the Hubble, right? So I don't know, I got lucky. I had the time to learn and find what I loved. But yeah, if you love programming and writing code, then for me, hands down, find a way to do that.